Well, it's episode 11, and I've finally interviewed a climate scientist. B. Rooney is both a scientist and a socialist. She got her PhD in environmental engineering and science at Caltech in Pasadena, California, where she also organizes with the Socialists of Caltech, a political club organizing on and off campus. Many members are currently involved with an effort to unionize the grad student workforce at Caltech. B has a lot of experience to share about balancing the demands of her research and her activism. While academia can be a really worthwhile pursuit, it also requires a lot of time and energy. And with students and postdocs constantly moving around to different programs, it can be really hard for them to connect with their community and put down roots. At the same time, it can be really great to get scientists and other academics involved in organizing. The Measure H campaign in Pasadena, a city in Los Angeles County, was a hugely successful grassroots effort that established rent control and eviction protections for tenants in the area. In this episode, B talks about her experience with the Pasadena Tenants Union, a major player in passing Measure H. Among the campaign's most active volunteers were a math professor, who found her skills in mathematical proofs also translated really well to drafting laws, as well as PhD students with the stats wizardry needed to track the numbers for an electoral campaign. Scientists can do a lot when they get together, and when they bring their skills and knowledge outside of the academy to benefit their community. In this episode, we'll hear what it takes to get together, get involved, and make change happen as a scientist. We'll also learn a lot about climate science, especially the effects of air pollution and how we measure and mitigate it. B shares her critical perspective on the state of air quality research, as well as outlining examples of how powerful that research can be. I think this episode will have a lot of takeaways for anyone who's interested in organizing or climate science, so stay tuned. As a quick note, if you like this show and want to hear more, please consider supporting me with a donation. Podcasting is a lot of work, especially because I'm working independently outside of my day job. If you want to help me turn podcasting into my career, you can visit the link in the description to donate. Also, rating and reviewing the show and sharing it with your friends are both super helpful. And now, on with the show. You're listening to Solarpunk Now, the podcast about politics, science, art, philosophy, and whatever else it'll take to get us out of this mess. Join us, and let's demand a brighter future together.
I'm B. I use she, her pronouns, though I don't care too much. And recently I was the field director for the Measure H Pasadena rent control campaign. And since then, I've been mostly organizing with the Pasadena Tenants Union, but I'm currently unemployed and considering some organizing job opportunities.
And your PhD is in environmental engineering, is that
Environmental
right?
engineering and science, but that's a very broad categorization. In undergrad, I studied environmental engineering, so I was in the engineering school, and I had a few research opportunities there, including a field study looking at how microbial air pollution was produced after expansive flooding in the area. Another field project looking at nitrogen oxide production from oil and gas fields in the Colorado Rocky Front Range, as well as a modeling project trying to figure out the source of certain methane concentrations in the atmosphere. I also did a minor in atmospheric and oceanic sciences, so had a lot more climate and meteorology studies than I would have otherwise just in an engineering program. And at Caltech, I got my PhD in environmental engineering science, but more specifically in atmospheric aerosol production from biomass combustion, so the burning of solid stuff that is from biology mostly. And that largely has been a modeling endeavor. So I'm the scientist that sits at the computer and not the one wearing the lab coat and measuring things, mostly just numerical modeling. So playing with these really big models and turning things on and off and changing knobs and stuff to see what happens and understand what's going on in the atmosphere.
So we're definitely going to get into the atmospheric stuff, aerosols, and air quality. I am just curious though, like what drew you to that field in the first place? It was just sort of happenstance. You had a really cool class, or if you've been interested in it for longer.
Yeah, I have always loved Earth and nature and environment. My dad was in the Air Force when I was growing up, so I actually spent 7 years of my early childhood living in Germany and specifically off base in just a rural farm town. We had more cows than people, so very small. um, and while I was there, I had a lot of freedom to run around the village, go play out in the valley and explore and stuff. I played on farms and in the barns and played with the animals and just kind of got to explore and adventure a lot with very little adult supervision, which was very fun. And our house was also on the edge of very some pastures looking out over the valley. And I spent a lot of time just sitting in our living room in front of the big glass windows and just watching storms roll through over the valley. Additionally, Europe is so much smaller than the US, and you have all sorts of, countries and cultures and stuff very compact in one area. And we really took advantage of that. And every spring break, and then pretty much every summer, very frequently in the winter, we would go travel to a neighboring or nearby country. And so I saw a lot of a small chunk of the world. And I was very shy growing up, so I didn't really interact with the people. But I loved getting to see all the different places and more specifically all the different kinds of earth structures there are. And it really just kind of came down to realizing that the earth is so cool and so beautiful, and that people are, they're just people. They look different, they sound different, they eat different foods, but they're just people. And so I was drawn to environmental engineering and science because it was a field where I could study what I loved, but also help people at the same time.
So speaking of helping people, I mean the way you introduced yourself in this podcast and a big part of what you're doing right now is actually activism. um, and tenant organizing specifically. But I'm curious if there are any like dilemmas or challenges you've faced as both a scientist and a socialist, if that's the term you would use, or if you feel like it gives you like an advantage or opens up opportunities.
Yeah, I would definitely call myself a socialist or communist. And right now, it's kind of hard to be both fully. Um, just partially the nature of academia and science and how it's conducted, and especially in the U.S. and the Western world, really demands a lot of your time and your focus and really your life. It's very hard to maintain the multifaceted identities that we have while being, especially a career-minded scientist.
Mhm.
Um, so I feel very split with my passions. I have a lot of interests and I care about a lot of things, but I have a big passion to learn and study and do sorts of science and stuff, but I also have a big passion to do things and make changes. And I'm mortal. I only have so many years on this earth, so it's really hard to be a scientist and let everything else go. And a question of what I want to accomplish in my lifetime, and is it become a really great scientist that really understands all the nitty gritty, that studied all these things, or is it learn enough to start making some change and create a better world? And I think I'm falling towards that latter part. And one of the really hard things in science as a socialist is where the money comes from to do the science.
Hmm.
Science is very expensive, depending on what you're doing. And right now, even science focused on environmentalism or health A lot of that money still comes from the military industrial complex, the war machine, those sources. So there's plenty of grants out there to go study the environmental effects of aircraft fuel on whatever base, wherever in the US. And it's like, great. But what about the rest of the world? And the fact that, the war machine is producing most of the worst shit. So that is really hard to contend with. Additionally, a lot of the labs out there, you might feel that, I'm doing something morally good. I'm trying to study what damages human health and the environment. But to do that, I have to go to this lab that also has their hands in all these dirty, wrong things. And that is just really, really hard to accept and feel good about. Additionally, in the environment of science right now in academia, it's pretty hard to be dedicated to your community or your family. It requires a lot of times moving from place to place until you're kind of a senior scientist. So if I want to experience other things or become really embedded in my community, I only got a few years of that before I have to move on to the next stage of being a scientist. And that's pretty sad to me. I moved around a lot as a kid, and I'm ready to really set down roots somewhere and really become part of that place and community. And science right now, I don't think is would really allow me to do that.
I'm really glad you brought that up. That's something I've encountered too, just sort of like looking at a potential future in academia and seeing like, oh, okay, wherever I get a professorship, that's where I'd have to be. And like it is
Yeah.
very it's this model of like this, I don't know, independent individual pursuing the truth and just like disconnected from community and
Yeah.
everything else around them.
Yeah, and I think it used to be a little bit easier. Nowadays, to be a scientist, you need your bachelor's, and then you need your PhD, and then you need to go do a postdoc. And it's becoming more and more probable that you need to do multiple postdocs before
Mm,
you can get a professorship or a position at a university, because it's just getting more competitive. There's not enough jobs, so people keep getting stuck in postdocs, and those are only 2 or 3 years. So,
right.
and there's only so many, universities or labs in a given area, so you're very likely to be moving again and again.
Yeah, it's chaotic. So speaking of community, do you want to talk a little bit about the Socialists of Caltech? Would you consider that an important community in your life?
Yeah, 100%. So Socialists of Caltech started around 2017, I think, and I was one of the founding members, not a founder, because I didn't know what was going on politically in the world or for my own ideology. But someone walked up to me and was like, "You seem like a socialist," and I was like, "I don't know, sounds good." And so I, started going to the meetings and figuring out what that was, and it was personally hugely important, but I think also important for the broader Caltech campus community and academic community in general. But we did, in the first few years, a lot of uh, struggle learning together, a lot of discussion groups, reading both theory and whatever articles, and basically working through it together. We started, maybe had around 10 people, and we all had different backgrounds, came from different places, different experiences, and had different bases of where we were at with political ideology or thought or any of that. And it was really valuable to just be together with all of our differences and think about the same thing, knowing that we had some similar idea that united us, which I think now we kind of might boil that down to the phrase like a better world is possible. It doesn't need a specific party ideology attached to it or whatever, but it's about this horizon that we can and want to achieve better for ourselves and for the world. So with Socialists of Caltech, we were trying to do a lot of things. We were doing discussion groups for our own political education, also some sort of science outreach, talking about socialism and science and more of the social aspects. Where does the money come? How is science conducted? who's affected, who's impacted, how is it misconstrued, all these sorts of ideas. But we also really cared about getting out of the academic bubble and into just the geographic community. And so for us, Pasadena, the LA area, the rest of the world, whatever it is, because you can't be a socialist stuck in one little portion of the world. And the academic world is a very narrow slice of humanity. So we majorly tried kind of getting involved in other organizing through the Tenants Union because everybody needs a house. It's a nexus of a lot of organizing and a lot of struggle. We're all renters. We're all going to be renters for quite a long time, maybe forever. And so it's just a obvious way to get involved, to learn about your community, and start making change there. And I think as a group, it was really important because we developed a comradeship through that communal struggle of the learning, but also activities we were involved in and actions we took. And it was great to be able to have someone you could call a comrade and rely on to push yourself to be better and push yourself to contribute to your community, and that accountability between people other than, the relationship of just friends or your family. It is a unique relationship that I think is incredibly important for myself. And I think our club starting and the development we had in the past 5-6 years has been influential on campus as well. At Caltech, it's an elite science and technology institution. There are a lot of people there who've had, obviously very privileged lives, who've come from families of academics with the whole lineup. For the undergrads, it's expensive. They go to the top schools already and have a lot of funding, probably privately from their family. And campus culture's pretty antisocial in the aspect that most people want to do their science and not really think about the rest of the world. I don't want to, maybe not most people want that, but that's kind of what happens. A lot of people, PhDs it's hard. It demands so much of your time and focus that it's really hard to do anything else. You don't have the time or energy for it, or just the wherewithal, or know the people, or how to get around town because you're so sucked into lab and whatever you're doing. And I think that starting a political club, and specifically a socialist club, where we're adamantly pointing out things that we didn't think were right, that we could improve on, things that were making people struggle and unhappy, or just changes we wanted to see, did bring out a lot of more conservative conversation too. And some of the conservatives became more visible. But I think it got a lot of people started on the conversations and actually asking themselves questions, and asking, the admin questions about, like, is this it? This is all we get? Recently, Caltech has started up their unionization process, and that was something we talked about when we first formed the club, was, can we unionize? And at that point, we're like, no, we cannot. There's no basis. We have no base of people. No one's talking about it. No one seems to care, And I think that having the club start the conversation and create space for things other than science, and for people to care about their lives here and elsewhere, has helped give some space for the unionization to happen. Not going to take all the credit. I'm not even involved in that now, but it wasn't possible when we started, for sure.
That's really great. You've turned the institution into a it has a social presence in the community that it didn't before.
Yeah.
So, as a climate scientist, or as someone who studied climate science, why are you involved in tenant organizing and not climate organizing, or something with more of an environmental focus or closer to your research?
Yeah, I think that's a great question, and one I ask myself regularly, but generally come back to the same answers. I think that right now, much of climate organizing still relies on actions by the powers that be to change things. It relies heavily on lobbying the government and politicians to do things. And to me, I don't see a lot of change happening that way. And overall, it feels like less direct action and also less democratic. Um, I prefer the vibe of chaining yourself to trees and disabling pipelines. Haven't gotten involved in that yet, but that feels more impactful to me. I think that a lot of the climate movement isn't explicitly anti-capitalist or anti-imperialist. If you take like the Green New Deal or a lot of other new actions of mainly policy change to help mitigate climate change, it still relies on the profit motive. And it's more about the technology and how we're getting our energy rather than how we're using it.
Hmm.
So, for example, they want to switch over to more, renewable energies, um, things like, wind power, solar power, things that require batteries, things to store energy, which largely needs lithium and other minerals. And that still means that we need to continue ravaging the global south for these things. And that is in direct conflict with my political ideology as a communist. And considering what we've already done in the South, that doesn't need to continue. I mean, you see uh, environmental activists very frequently, especially in recent years, being assassinated by members of the timber industry or by, political powers. And it's just changing where we get our energy from is not the solution. We need to change how we're using our energy and why we're using it. And it will not happen in capitalism. It will not happen in an imperialist state. Like, capitalism cannot survive on balance. It demands constant extraction from the earth and constant exploitation from people. It
Hmm.
must take and take and take, and it cannot give back and it cannot restore. Capitalism wouldn't be if it did that.
Right.
So that's the major thing for me. I think there needs to be more acknowledgement of that, of our economic systems and class struggle and environmental justice. And I think a lot of people are recognizing that and moving towards that. I feel very inspired by the youth movements. They seem to see the imbalances in the world, and it's not just about fossil fuel or wind energy, it's about
Hmm.
everything else. And yeah, and so that's kind of why I do tenant organizing. I think sort of the revolution starts at home. We all need a house. And you could even say this is tied to environmental things. If we have to move every couple of years, instability does not help sustainability. We're bringing around moving trucks all the time. We're producing so much extra crap every time you move,
Yeah.
those sorts of things. I mean, I'm not involved in the tenant struggle because I'm like, this is going to save the environment, but because it is a fight towards the community, societal, economic structure that would be necessary to improve the environment anyway.
That's a beautiful answer. Thank you. So, the main thing I want to talk about today is your research with air pollution, air quality, the sources of that, the reasons it's a problem. But I wanted to start with sort of I guess, a climate 101. I'd say that probably the audience for this podcast already has a pretty good grasp of climate. I don't think there are any climate deniers. I'd be surprised. I don't know what
Yeah,
the value in this is for them. But maybe more of like a like college undergraduate level explanation would be cool. Like if you were teaching an intro course, just sort of getting the conversation a little bit beyond, we're emitting stuff and it warms the planet and that's bad. Like that's all true, but it's this very simplified story. So I'm curious, there are different kinds of emissions. Would you say some of them are worse or more of a problem to be tackled first? Or like what are the sort of
yeah,
different classes of emissions involved, I guess?
right. So we'll also want to think about sort of the distinction between climate change and air quality and public health. They aren't one and the same. They definitely overlap, but things that are important when thinking about climate change might not be as important when thinking about immediate health effects. So, CO2, carbon dioxide, everyone knows this as the major greenhouse gas. Um, CO2 is pretty bad to breathe in if you have nothing else, no oxygen. That's not good. But that's not the main issue, right? The main issue is that it is a greenhouse gas and it's dramatically changing the energy that we're getting to the earth. Um, for air quality and health, we might also think about things like particulate matter or aerosols, or ozone, nitrogen oxides. These things do impact the lungs and the general health system of the body, but they don't interact necessarily with radiative things in the climate change as much. So that's just a distinction that kind of has to be thought about. For climate change, you have, um, greenhouse gas system is kind of the main thing happening there. So we have a lot of chemicals and compounds in the atmosphere, and we also produce a lot of different things. We produce CO2, we produce methane, nitrous oxide, blah. Those three things are common greenhouse gases, and most of the focus is on CO2. However, CO2 is one of the weaker warming gases. Instead, methane is actually 15 times stronger as actually even maybe even more than that, for its like warming potential. However, methane has a much shorter lifetime in the atmosphere, so it doesn't have as much time to do that warming. It falls out or it's like rained out faster. CO2 has a lot of varying lifetimes. It's a very complex circulatory system on Earth. But nitrous oxide, which is a compound from fertilizer largely, is way stronger and actually has a way longer lifetime than methane. However, that one we don't emit near as much compared to CO2 and methane. So, if we're just trying to make the greatest impact, we might want to target CO2 or methane. It also depends, what do we have control over? The Earth naturally, not from humans, has stuff and produces greenhouse gases too. There's methane that's like, in bogs or in permafrost that can come out. Plants actually off gas various compounds too that can react and do things in the atmosphere. But we're not going to go destroying the bog so there's no more methane, or, we shouldn't do those things. I'm sure someone someday will be like, yeah. Instead, maybe the idea is maybe we shouldn't have a 3-ton CO2 producer per person to get to work every day, cars.
Right.
So, a little bit more about aerosols because they're very important considering climate and health, but they're very complicated. So, aerosol is a very general term. It means a solid or a liquid particle suspended in a gas. Aerosols can be made up of different chemicals. They can be different sizes. They have different shapes and surface area, different ways they react and do things in the atmosphere. And they can be as small as a couple of nanometers, really, impossibly tiny things. And they can even be particles that you can see in the air. So windblown dust and sea spray, smog, haze, you can see that stuff. That's also an aerosol. Clouds, even. And we've been measuring particulate matter for a long time, and it's had very obvious correlations to health impacts. Basically, you can look at the concentration of particulate matter in an area and look at the incidences of hospital visits or early death, blah, blah, blah. And it's just obvious. It's a good measure that health is going to be bad. However, we don't know that much about which specific kinds of aerosol are worse than the others and which sizes, because once it gets into the body, it can do all sorts of things. And we're not even positive which property is the most relevant. Maybe it's the specific elements that are in that compound, or maybe it's actually the shape and the size because of how it might mechanically interact with the cilia in our nose, or all the branching in our lungs, and can it get into the bloodstream? That's very complex. So we just do a big measure of PM 2.5, which is particulate matter under a certain size regime.
Right. Definitely have spent a lot of time tracking that number on my phone as a
Yes.
resident of California.
Yeah, same.
So speaking of measuring that, let's talk about air quality models, or AQMs.
Yes. So air quality models, it's a numerical model that we create and run on a computer. And they typically kind of represent, or they could represent, the state of the science. So the really in depth, comprehensive air quality models kind of incorporate all the bits of science that we know that we can have equations or parameterizations for, some sort of numerical representation, and use those to predict circulation of chemicals or air pollutants, whatever you want to look at. So it can incorporate emissions, so what we're putting into the air, what is getting put into the air just naturally from earth processes and whatnot. It can also take in the chemical reactions that are happening there, the thermodynamics, the physics, the airflow, the meteorology, all of that. It can also include surface interactions with the air and the ground, or with the air and water, all sorts of things. So you can see very quickly that this gets very complicated. If you pick out even one part, say just the emissions, this is a huge, important, really driver of what you're going to get out of your model, is what you put into it, is the emissions, because that's so much stuff, even just human wise. We have cars, we produce energy, like how the production of energy happens. We burn all sorts of things for all sorts of reasons. We have industry and this and that. Like, that's hard. It's hard to create an inventory of those as well. And we have some good ones, and we have some really good estimates, or what we think are good estimates. But it can get very quickly complex. You can also change the complexity by deciding which compounds to include. I said aerosol is a really big category of things. Do we want to just say, give me everything that's a particle that's less than this size? Or do I want to say, I want to know exactly what compound that is? Like, does it have carbons in it? It's got some hydrogens, the sulfur, what's in it? So quickly it can be very complex. But essentially, the model, you can imagine you have some map. It can be the globe. It can be 80 kilometers by 80 kilometers. It can be whatever you want. And then we chop it up into little boxes. And in each box, we take all that science we know, all the equations, all the parameterizations, all the numbers, and we crunch all the numbers in that box at that time point. And we do it in every box at every time point. And then we see how, that one box affects the next. And that's kind of how it develops the whole picture, to get an idea of what is the air quality, how is this pollutant transferring over space to another area, that sort of thing. Millions of equations. Very big, slow.
Must need really beefy computers, huh?
Yes. Actually, that is another point of contention for me. It takes a lot of energy to run these supercomputers. A lot of energy. You can go down into the GPU room and it's hot in there, because just how much energy it takes to do this, and all the little motors that are running, all the little fans. And honestly, I kind of feel like maybe we should not use that energy and maybe do something instead. That's like, I know it's really bad. The environment's not doing hot, so why don't we do something else?
That's a conundrum.
Yeah.
So I'm guessing, since, these models are themselves really complex, incorporating a lot of different, formulas and concepts and things, and also the things that you're modeling are complex, and it's not a complete picture. So I'm guessing there are like strengths and weaknesses of these
Mhm.
models. Would you say there are things that they're really good at and things where they're just not?
Yeah, there's constant improvement, or like new methods and new things that people are doing and expanding on. So it, really depends on what questions you want to ask. And you can use the models kind of in two major ways: in a forward manner or in an inverse manner. Meaning, forward is like, I know the emissions, I'm putting them in, and then I want to see what happens to the concentrations in the atmosphere. The inverse is more like, I know the concentrations in the atmosphere. Can I figure out where they came from? Go backwards. And so both are being used. A lot is being thought about the inverse models, especially with so many satellite measurements and observations. We're trying to use that to figure out to better apportion the sources of those things. And we can also use the model to kind of test our knowledge or our hypothesis of a new process, because you can do all these tweaks, and you can run 20 versions of something and see how, like, if I took out this one piece, or if I changed how I parameterized the wildfire plume structure or something, like how different did it get? And we can use real observations and measurements to compare that and see, like, oh, if I incorporated my new process, do I get closer to the actual observations we saw that day? And that can be helpful on a pretty good on a broad scale. Like, I'm really was blown away when I was doing this very complex thing, very complex simulations after, many years of PhD, and then I finally get the results that I'm looking at, and it shows the concentrations of where the high PM 2.5 values are, and it looks very similar to the satellite image of smoke you could see, or something like that. It's quite impressive. However, there are a lot of uncertainties. So, like I said, the emissions inventory, that's just like a million parts, and we don't know the exact numbers. Also, we have so many mobile sources of emissions, so cars, and anything that's moving around. A factory staying in place, that's much easier. But if your emission emitter is now like moving around between boxes, that gets even harder. Um, it also depends largely on what scale you want to look at. So you could make your resolution of your model like a 1 by 1 meter box. And people are starting to do a lot of that to look specifically at air pollution in an urban environment in a city, and not just broad kind of background stuff. And it shows it can vary block by block. Like, it's pretty intense. But you can't get that same resolution if you want to look at the whole globe. That would take a cajillion years to actually run that model.
Yeah.
But also, you start to get error propagation. So any little error or uncertainty or wrong estimate you had in there, the bigger your model is going, the more things you want to get out of it, the more that error is going to expand and make it worse and worse. So another kind of limiting factor is the computer science and engineering itself. The computer's doing a ton of calculations. It takes a lot of time and energy. But there are improvements to be made to computer science and the technology that could, maybe a quantum computer could do these things way faster with much less energy, these sorts of things. I can't say much more about that, but that is a significant part of the computer model, is just the computer part, not the science you're putting into, but just how these processors are communicating, and whether or not there's a blip here, if that really wrecks everything, or if it could kind of recover from that.
Got it. I want to segue into a more specific example in your research. So you have a paper studying emissions specifically from cook stoves in India, rural cook stoves specifically, so burning like solid fuels like dung and wood and like various combinations of the two. Everyone's got their own blend.
Yes.
So I want to sort of get into the applications of these air quality models, and or like how we're measuring air quality in like labs versus in the actual world. And there's all sorts of issues. I mean, we could talk about this stuff forever. Just like the air
Yeah.
quality models, we could zoom in as much as we want. But I guess, could we start with a brief overview of this paper on rural India, what you found, what you were looking for?
Yeah. So the paper that I wrote was part of a much larger project. And you'll notice in my publications, there's like 30 authors on all of them, which isn't necessarily the case for most academic publications, because these models are so big and involve so many things. You can have a chemistry pro, but you're also going to need a thermodynamics pro to help you out, and someone that knows the emissions to get them plugged in. So there's a lot of groups that were a part of it. But what I was specifically doing was using data on the emissions gathered by another group. Both they had field measurements, so they went to this rural region in India. It's a bit south of New Delhi and Haryana. Importantly, They say rural, they say villages. It's 200,000 people in a small
Oh my
area.
God.
Yes, India has a lot of people in that. That was a very important perception to understand when thinking about this. So there was a group taking measurements, like in the plume of the cook stove while people were cooking, like very, very realized it's happening in situ. Um, and they also had some things where they would collect the emissions, so like a kind of a filter or canister, and they would take those back to the lab and then analyze them with mass specs and what other lab stuff that I never learned because I was doing computer stuff. Um, and so they're getting things like the rate of emission, so how much, how fast, also the composition, so specifically what chemicals are in there. And that was a big base that I needed for the model because I need the emissions input, and specifically the very fine grain from cook stoves, not from the residential sector, not from a rural sector, like from cook stoves, because the main tactic method I was using to kind of ask the question, how much particulate matter pollution and the ambient air quality, ambient air comes from cook stoves. Not how much comes from this region or how much comes from indoor stuff, but specifically cooking. Um, and to do that, basically we took a typical emissions, full emissions inventory. Everything's happening as it does. People are cooking, people are turning off and on their lights, they're driving, factories are doing the thing. And we run the model, see what the predicted air quality looks like. And then we do this sort of the same thing by extracting and just zeroing out the emissions from the cook stove. So now we say, let's do everything is normal except nobody cooks ever. What happens now when we do that simulation? What does the atmosphere look at? And then we can kind of compare those. You can make it a little more nuanced by saying, okay, what if we double those emissions or half those emissions and get an idea of the sensitivity of the model to those? Like, did it just change a little bit, you know? So that was the main question we're asking. How do cook stoves that burn solid biofuels contribute to outdoor air quality, particularly PM 2.5 was the main thing I was looking at, not really looking at gas compounds, but PM 2.5.
So these stoves, they emit a lot, right? They're pretty.
Yeah.
I don't. Would if inefficient be the right word? Just like for how much energy they're producing, it's just a ton of emissions.
Yeah, there's a lot of emissions, and it varies greatly by the exact fuel you're using. So, wood, what is wood? It's trees. Okay, but there's a million kinds of trees, and people use different wood. Dung as well, depends on the animal, depends on what they're eating. So, like, they're all variable. Additionally, cooking the food, not the fuel, but the actual cooking the food, that produces its own stuff. You walk into a kitchen, you smell something good. It
Mm-hmm.
emitted something, you know. Um, so those can kind of complicate each other.
Yeah. So the reason I'm so curious about this is because I don't know if this is happening so much anymore, but for a while, a lot of environmental activists were very concerned. I don't know if it's totally fair to call them environmental activists, but that is a very broad category.
Mhm.
They're very concerned about these stoves, and it kind of has the echoes of the same like fear that people had after what was it, Paul Ehrlich's book? A bunch of people talking about overpopulation, and the kind of subtext there is it's overpopulation in the global south is like what's causing all these environmental problems. So I just wanted to get a perspective of a scientist who's actually been studying this stuff, to sort of like put these fears to bed, I guess, about
Yeah,
you know people cooking with wood and dung in India being like the thing that's destroying the planet, because I know that that is an argument that gets put forward, and it's just like it's really scary. It's ecofascism, it's eugenicism.
yeah, exactly. It is eco-fascist and eugenicist. Like, yeah, number one, overpopulation, bullshit. Number two, it's true. The cook stoves, and because there are so many people using them, do produce a lot of pollutants. Those pollutants, I think the bigger importance is to directly to public health rather than the environment, kind of climate change as a whole. And largely that stays somewhat regional, like the emissions that India produces from cook stoves kind of stay, it flows all over the world, but the people in India and the surrounding regions right there are going to be impacted most from that. And I do think in a lot of these cases, people come with kind of the savior complex that these people are, they're primitive and they're not smart and they're making bad choices or whatever and blah 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 blah. And it's like that's just not the case. There are a lot of reasons why they use those stoves and not other things, and a lot of that is material, and sometimes it's cultural, but yeah, it is true that pretty much any combustion process is harmful. Combustion is harmful for humans, and it produces stuff that's going to hurt the climate as well. Combustion does happen naturally on Earth too. Wildfires do need to happen sometimes, not on the scale they're happening now, but that happens. So from my study, we attributed about 30% of the PM 2.5 in that region from cooking, and it's particularly at cooking times. If you look around the time of breakfast and dinner, you would see a huge spike. That makes sense. So it is significant. And it's not easy to solve that. We're talking about tons of people. And we're talking about something that's been integrated into their life and their history for a long, long time. People want to cook certain ways. They know how to cook certain ways. Sometimes it's what they're used to, but it's also what they like. And the transition to maybe something that's like healthier or better for the air quality, that costs a lot of money and that takes a lot of organization. Frequently there are like government programs like subsidies to make this easier on people. But you also have to think about what infrastructure is currently there. If it's not a super electrified area, we're not going to be able to use an electric stove. And anytime you're introducing a new technology somewhere on a broad scale, like, for it to be successful, it needs to be embraced by the people in the community there. They have to be willing to use it, and reliable on using it. And they have to be able to learn how to use it and be able to teach others and carry that on. And with a lot of these groups like Engineers Without Borders, or kind of other Western scientific missionary groups, we're going to go make a clean toilet and get clean water for this or that people, like, they don't really come with a holistic cultural centric view. They're like, come in, here's my dope technology, it's super cool, and it is cool, and then they leave, and then 3 years later nobody's using it. People also need to have some ownership, over it, to feel responsible and obligated to carry it, but to have that control, to be able to maintain the system and keep it going, and to be flexible to embrace that as part of their routine and their culture. Not everybody wants to do that, and that is what it is. But we can't just come in and airdrop a bunch of new stoves and be like, woo. It takes a lot more care, and planning, and ultimately I think self-determination needs to be the core of these changes.
So, I mean, just to quickly put this in perspective a little bit, like you said, these emissions are mostly just significant at the local level, right? It's in terms of the grand scheme of like what's actually causing climate change, this is much more of a local public health issue, and the emissions from the global north are much more of a problem even before we factor in things like how so many of the products that we buy are made in polluting factories in other parts of the world.
Right. So what I was saying about the India cook stove study is it is sort of regionally contained. However, there are estimates that on a global scale, PM 2.5 from the residential sector everywhere, not just India, contributes to about a quarter of the global burden of disease. It's a measure of poor health, kind of. However, The residential sector is not contributing much overall to greenhouse gas emissions. So again, that's sort of the distinction of when we're thinking about climate change versus health. They're not exactly the same in their trade-offs. I don't think the residential sector is the problem for the climate. It is critical for health because that's where you live, but it's really not you're not going to fix climate change by making everyone have a perfect stove. And additionally, very recently in the US, there's been a lot of discussion about gas stoves and whether or not we should ban those. Gas, relatively cleaner and more efficient than solid fuels, but it's still gas, you're still combusting, there's still bad stuff, and it does contribute significantly to especially like asthma in children, but broadly cardiovascular, cardiopulmonary things. So combustion is bad no matter how you do it. Even, because the combustion reaction equation, when it is totally pure and there's no other random crap in the way, produces CO2 and water. Like it always produces CO2. Very frequently, it produces all these other crap, sulfur stuff, nitrogen stuff, all these other organic compounds that go into PM 2.5 and all that. So it's just bad. Um, so, but largely the residential activities, things that we're doing in our home, are not what's driving climate change. And I would say your recycling is not saving us. I wish it was, but don't have a panic attack when you can't find a recycling bin. It's not going to happen that way. The brunt of it is from the capitalist idea to consume, to produce, to take, and it's just wasteful by nature. And we're in a system that needs balance to exist, and we can't just keep taking.
Mm-hmm. Just to sort of close out this, I guess, like case study with your research in mind, but also sort of stepping outside of it for a bit. Like, if you imagine the ideal scenario here, where we improve public health by replacing stoves, not just in this place in India, but like, even our gas stoves in our apartments here in LA, or, wherever in the world that this residential combustion is having localized negative health effects. What would be a just transition in that sector? How could we improve public health when it comes to the dangers of aerosols, but with respect to, public input and democracy?
I mean, initially, people need to understand what is happening and that it is harmful to themselves. Not everybody fully understands the level of danger that it is, especially when it comes to something like food. You're like, I gotta eat. So yeah, number one, there needs to be education within the community, and I think also a cultural shift to I don't mean India, specific, but everybody. A cultural shift in having a shared responsibility in community, that their cook stove does affect the neighbor, that sort of thing, and the agreement that improving one person's health will improve everybody's health. And it's going to come down to probably a lot of localized power structures. What can people get? What is their infrastructure like? So what can they come together and organize to get from the government, or what they need infrastructure wise to do these changes? And a lot of times that might not be the top priority of like long-term health effects from whatever, especially from something that you need to live, cooking and food. Um, and so maybe that community decides, a better path forward to a more impactful change is considering our car use or something else. So there's a lot of decisions that people need to make, and that are based on priority and value, and also the recognition of a mortal short life that we have to contend with. Um, yeah, I don't really have a great answer because I don't know. I was one of the Westerners that I've not gone to India. I've not been in the villages that we were studying. I don't know what their day to day life is like. I can kind of learned bits and things, but you're going to have to talk directly to whatever those groups and people are to really figure that out. And largely that doesn't happen. So
Right.
that's a good place to start. Talk to other people with better answers than myself.
That's a great answer. Yeah, I think probably the best takeaway here is that you don't just airdrop a stove. Like, we already know
Yeah.
that doesn't work, and we've got our own stove problems.
Yeah.
Like, I have a terrible stove. It leaks for several seconds before any flame comes out.
And maybe by the time, those 200,000 people have a liquid petroleum gas stove, and it's working and they're using it, maybe by that time we realize how bad liquid petroleum gas stoves are, or we come out with an even better technology, and what, we just leave those people in the dust because we just spend all that time getting them the second best tech, or like, where do we stop?
Yeah, no, I totally appreciate that. Like, I'm more interested in honest answers than complete answers. So I guess we can zoom back out a bit now, just to sort of close out. I'm curious what you're excited about for like the future of air quality research, how you think it can help people, either in a climate sense or public health sense, which is a distinction I'm going to practice using now. Thank you for that.
Not entirely separate, but yeah. So I think there is an increasing focus on this idea of justice, and the recognition that everything is in a system, a very complex system that you can look at in little chunks and pieces, and those are all individual systems, but they're all interwoven. And I think there's more recognition of that, and I think that focus will be where we can really find solutions. I think it's more in coming up with like innovative systems rather than innovative technologies. The stove itself is not the problem, or rather, it's sort of a necessity maybe. So, bringing in the disciplines of study like sociology and human behavior and economics and how we are structuring society is becoming more and more an environmental topic too. That's probably going to be less numerical models, but that is what excites me, is people bringing in the human aspect and thinking about what if instead we change this really broad human behavior or demand of us needing to drive at least 30 minutes to go to work or to the store or to wherever. That's really where I'm excited about. I'm not too excited about knowing what exact species of gas is doing the exact rotation of this radiation with that thing and all that. I'm very much a big picture systems kind of person, and I think that's where the solutions lie. There's a lot of looking into technology to scrub CO2 from the atmosphere to grab these pollutants, like whatever big filters or things you can imagine. That's great, but it's not that those are band-aids. We need to address the wound itself,
Mm-hmm.
and what's creating those things, and that's our systems and our values as a whole. And I think that's becoming more prominent, but that's becoming less the typical kind of academic hard science stuff. People don't kind of group those together as much. That's why I'm ending up kind of an organizer rather than being in a lab somewhere, to really exact those system changes that are necessary.
Right. So with that being said, I mean, I heard just there you don't sound too excited about the future of these computational models specifically. So,
Yeah.
where are you hoping to go from here? Like, what does the future of your research or your field look like? What sort of contributions do you want to make?
Yeah. So I don't think numerical models or any of the they're very cool. They're very fun and intriguing with a scientific mind. They can be very useful into studying things, and we've learned a lot from them. For me, I feel like we've learned enough about a lot of the things. What we have found is that it is bad, it is getting worse, and we've identified a lot of things that are greatly contributing to the problem. I'm like, great, that's all I need. Let's go. We have more than enough food for people, yet there are starving people. We have more than enough houses for people, yet there are empty homes and homeless people. We have the technology, we have the resources. We need to, redo the system to really access those things. And so for me, I'm not probably going to be going into sort of career, professional, academic oriented science. I would like to be more in the implementation of new practices, or like the creation of community gardens and solving food deserts. Maybe, urban planning of how do we create a city that works with this many people, and, if we have a ton of cars and we're keeping the cars, how do we make that work? Or how does this building or business or organization be as sustainable as possible, produce as little waste as possible, use as little energy as possible, those sorts of things. I don't, my action on those scales is, and even if a lot of people did that on, is is not going to prevent climate change, but it is going to provide us with practice that we need of just thinking about things differently, valuing and prioritizing different things. Where if, this business is doing all right and they're making enough profit and they have enough room to be like, okay, well, I don't need to produce this much waste and make this much packaging on my thing to, my business, I'm going to still get some money at the end of the day. So I might as well think about these other things instead.
Mm-hmm.
That sort of stuff. I'd much rather get my hands dirty and start doing things. Also, I'm so exhausted of sitting at a computer. I want to use my body again. I forgot how to use it. And, just those other things would be great. And I think immediately more impactful materially, and preparing our mind and values and culture for the ultimate change that we need to survive on this planet.
Totally. It sounds like that scientific perspective, both personally for you and also just the fact that the science is out there, is still helpful. Like, that's still a part of your outlook, but you really want to like apply it, and not like applied research, but applied, action, doing. Yeah.
And I don't, science is, fun and obviously useful and all those things. And people are very passionate about it. And I want a world where people can fully explore their passions. And for me, I don't think I could fully explore my passions in science right now in the way that world is.
Mm-hmm.
But, I love when people are happy doing what they're doing. That's great. But for me, I'm getting antsy. Gotta do something.
Yeah. So just to close out, zooming all the way out now to the global perspective, or maybe even beyond that, what does utopia look like to you?
Ooh, even beyond that. That's fun. Yeah, so number one, capitalism is gone. Imperialism is gone. We have access to, by we, I mean everybody that wants it, has access to clean air, clean water, good food, secure and joyful housing, education, healthcare. And health in this world, I think, would be defined differently. It would be defined by the individual, what makes them happy, what makes them comfortable, what they want and need in their life for their own desires, and not what everyone else has said is a healthy or appropriate body and lifestyle. Just, are you happy? Great, doesn't matter. Moving on. And I think, this would take a very considered, planned economy and societies and structures based around community and not the profit motive. And I think a lot of our values would change. We would value things like music and art and creation and relationships, and that those would be at the forefront of our lives, and we would express ourselves through creativity and through the things that we do, rather than the things that we buy, like phone cases and whatever those little things are that people put on Crocs now. I'm participating fully in capitalism right now, guys. I'm all definitely doing that too. I have a personalized phone case. Don't worry. But that, the focus would shift and life would slow down. It's awesome. We can communicate live across the globe, like literal fractions of a second. That is crazy. We don't need to. or we don't need to all the time, or have the demand of like, everybody is kind of always on the clock now because there's 8 million ways your boss can talk to you at any time of day from anywhere in the world. And so there's just this expectation that you have to respond and you have to do the thing. And it's like, we don't need to produce this fast or do this stuff this fast. We're going to be okay. We have amazing medicine. There's a lot of problems to solve, but, just a big breath, and people can focus on being and experiencing what is around them when it's around them, rather than going from one place to another trying to get somewhere or achieve something, but they're just experiencing life, everything that it has to offer. And largely this will need the recognition that we are animals, we're of nature, we are part of the ecosystem, we have a whole ecosystem inside of us with our microbiome, like levels upon levels of like, we are it is us, we cannot separate from it, we need to recognize that. And our physical communities should reflect that. Our homes should be near our culture and near our economy and near our nature and life, and nicely just tied together. One random thing, very little cars, maybe no cars. I want to see some trains everywhere. I want to see some old school trains where you're doing this thing,
Yeah.
Mechanical things that aren't, combustion based. But also, I have this obsession of one day when I'm in utopia, my main job would be to run the junkyard that has turned into a materials and parts and items library, where people just bring you their waste and you're all right, let's go. What do we got here? We can use this. Someone can use that. And there's going to be a lot more art. So if you really can't find a purpose for it, someone's going to make a sculpture out of it. And you're like, great, we got it. It's good. It's used. It's not decaying into terrible, gross things. Another big piece relating to the tenant organizing, I don't think that private property would exist in the same way. I don't think there'd be landlords. There would be no one that could throw you out onto the street. What that means for ownership doesn't necessarily mean, you can't own anything or whatever, but like, you're not at risk of dying because someone wants to make a profit. And, this utopia, we wouldn't be showering every other day even.
It sounds like you've thought about this a lot.
Well, preparing for the interview itself I've thought about a lot of these things, at different points and segments, but sitting down and really creating that comprehensive picture is the first time I've really done it. And a very fun activity, really good. Yeah.
Awesome. Well, thank you so much for sharing.
Of course. Thank you for having me on.
Solarpunk Now is written, hosted, and produced by me, Luca Dowell. The Solarpunk theme song is by Red Keener on SoundCloud. My guest today was B. Rooney, an environmental scientist currently with the Pasadena Tenants Union and Socialists of Caltech. You can find links to her research, as well as both of those organizations, in the show notes. Follow me on Twitter at SolarpunkCast, Mastodon at SolarpunkCast@spore.social, or visit solarpunkcast.net for all episodes, including show notes. You can also visit solarpunkcast.net to donate to the show. Running a podcast takes time and money, and I do all of this myself, so your support is greatly appreciated. That's solarpunkcast.net, link in the description. And remember, the realization of any vision requires action. I strongly encourage you to get involved with local organizations whose goals align with the brighter future you want to see. Analysis is important, but we have to back it up with practice. Keep dreaming big, and keep up the good work.